awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Alright, so now question number 4. So figure 5 shows a block held at rest at the top of a 15-meter long rough slope with a coefficient of kinetic friction. So the block slides down when it is released from 9-meter height. Okay, so means that the displacement traveled by the block is given 15 meter. So kotak ini boleh bergerak turun ke bawah disebabkan ada gravitational force. Gravitational force tu adalah dia punya berat lah, the weight of the block. Okay, so we need to draw the free body diagram first. Since this is the surface of the inclined plane, so the line that is perpendicular to the surface is y component. Okay, and x component. Okay, so means that we're going to have wake straightly downward. Okay, and then remember the angle. Angle here kita tak tahu. Okay, so we consider angle kat sini kita kena kira lah. Okay, so the angle here is theta. Okay, so we're going to have sin theta is 9/15. So we consider that 15 is actually from here lah. Okay, sebab dia dah kata dah tadi. The block slides down when it is released from the height of 9 meter. So from height of 9 meter, so they start from rest at the top, of a 15-meter long rough slope. So from here we can calculate theta, which is the angle is equal to 36.9 degree. Okay, so means that angle kat sini pun samalah 36.9 degree. Jadi apa lagi force yang ada? Mestilah frictional force. Kan, in this direction. Okay, jadi kalaulah saya resolve W saya kepada WX dan juga WY, so you boleh nampak dekat sini WX inilah yang menyebabkan objek itu boleh bergerak turun ke bawah. Okay, sebab dia ada berat dia kan, gravitational force. Okay, dan satu lagi adalah dekat free body diagram kita jangan tertinggal, so normal force. Okay, so now calculate the final speed of the block at the bottom of the slope. Okay, so bila kita nak kira final speed, kita boleh kira menggunakan work energy theorem, where W net is equal to the change of the kinetic energy. So W net tu adalah total work. Okay, total work. So kita boleh kira juga gunakan formula Fs cos theta. F net S cos theta. In this case, theta kita adalah 0 lah. As in this direction, F net pun mesti same direction. Sebab itu bila ada daya bersih, yang same direction dengan displacement, objek itu akan bergerak pada arah itulah. So daya bersih tu mesti sama arah dengan dia punya displacement S. So this one should be 1. Okay, jadi untuk pakai kedua-dua equation ini, kenapa saya nak guna W net equal to delta K? Sebab saya nak kira dia punya V. So I will use this equation, which is W net is equal to half mv squared minus half mu squared. So U start from rest, so this one should be 0. So yang saya nak cari adalah ini, yang saya highlightkan dengan warna hijau tu. Tapi saya tak ada nilai W net, so saya guna equation satu lagi, which is F net S cos theta. Okay, jadi bila saya nak guna equation ini, dia ada dua cara you nak kira W net. Saya selalu pesan ada dua cara, sama ada you nak kira asing-asing, which is the work done by Wx plus the work done by the frictional force. You nak kira asing-asing pun boleh, tak ada masalah. Kalau you kira asing-asing, so dia akan jadi work done, work done by the, saya buat tulis kat bawah So kalau you nak guna yang ini, you kena kira work done by the weight ataupun gravitational force. So in this case, kalau you resolve W kepada X dan Y component, kalau you kira asing, you tak perlu resolve pun tak apa kan. You boleh je ambil angle antara S dan juga W. In case kalau you tak nak resolve lah. Maknanya kalau you nak resolve, then kita akan pilih. Bila you resolve W into X and Y component, we choose the force that is parallel dengan S. So Y tidak kan? Y is perpendicular dengan S. So we choose WX. So dia akan jadi, okay, work done by WX is equal to WX S cos 0. So this is equal to 1. So WX is actually mg sin 36.9 degree times dengan S dia adalah 15. Boleh kalau you nak kira asing. Okay, sama juga dengan frictional force, work done by the frictional force. You nak kira asing, dia akan jadi Fs cos 180 degree. Kenapa 180 degree? Sebab S is in this direction, tapi frictional force opposite direction. They are 180 degree. S turun ke bawah, tapi frictional force ke atas. So macam ini. Okay, so you akan dapat -1. Okay, this one is -1. So, frictional force, dia tak bagi kan? So, kita kena kira lah, dia bagi mu saja. So, mu n times S. Di mana mu dia dah bagi 0.18. Tapi normal force, jangan risau, normal force is equal to WY. Normal force is equal to mg cos 36.9 times mg, which is the mass is, kita masukkanlah, mg cos 36.9. Okay, and then times 15. Okay, so dapatlah tu kira dia punya work done by the frictional force. Itu kalau cara you nak kira asing-asing. Lepas awak dah dapat work done by WX ataupun work done by W, boleh pula kira pula work done by the friction. Sebab tu tambahkanlah. Okay, ingat kalau awak nak kira work done by the gravitational force, awak resolve W ini kepada X dan Y component. So you choose the force that is parallel dengan S, iaitu WX. Sebab itu kat sini kita masuk WX. Ingat mungkin ada student, dia nak kira work done by the gravitational force, dia nak terus masuk W. Boleh tak? So saya kata boleh je. Dia akan jadi Fs cos theta, dia akan jadi Ws cos theta. Okay, cumanya dekat sini angle theta ini bukan kosong lah. Angle dekat sini you tengok. Okay, you tengok S awak ke mana? S awak ke sini, direction dia, and this is the Y component, and this is X component. So W awak ke bawah. Ada yang nak ambil terus macam ini. And then angle dia mesti ambil angle antara S dan W. Okay, kat sini. Ini angle yang kat sini. Sekejap, saya kena guna warna hijau. Angle yang kat sini. Okay. So kalaulah angle dekat sini adalah, jadi kalaulah angle dekat sini kita kira tadi theta 36.9, so means that angle yang kali hijau itu adalah 53.1. Boleh? Awak akan tengok nanti jawapan pada sini, okay, WX ini, yang saya highlight dengan warna purple ni, dia akan sama dekat sini. Yang awak kira dekat sini atas. So, dia akan jadi mg, weight dia adalah, and then times dengan displacement S. Cos theta tu tak boleh lah cos kosong. Dia adalah 53.1. So, you akan dapat jawapan berapa, berapa joule kat sini. Okay, boleh so, jawapan yang colour purple kat bawah tu dia akan sama dengan kat atas tu untuk work done by the gravitational force. So, it's up to you. Awak nak kira work done by the gravitational force, awak nak resolve W kepada X dengan Y, boleh. Ataupun you nak ambil terus angle antara S dengan W. Okay, itu satu. Kedua, untuk you kira the net work, okay, you can total up W WX plus WF, you kira asing-asing and then you total. Ataupun you buat cara yang macam ini, maknanya you masukkan terus Fnet. Okay, Fnet tu apa dia? Ini. Fnet tu ini dia. Okay, maknanya dia turun ke bawah. So, net force is equal to WX plus negative friction. Okay, so saya buat kat bawah tak muat ni. So, dia akan jadi, sekejap saya tulis kat bawah ni. So, W net, dia akan jadi F net, which is WX plus negative friction times S. Okay. So, in this case, awak cari the net force. This one. Ini. Awak cari ini dulu. And then awak terus darabkan dengan displacement pun boleh juga. Okay, ini cara yang seterusnya lah. So, WX tadi kita dah tahu dia adalah mg. Ini panjang ni equation ni. So, dia akan jadi mg sin 36.9 and then plus minus, so minus frictional force which is mu mu n. Kali ni n dia apa tadi? N dia adalah normal force equal to wy which is mg cos 36.9. So this is mu k lah. Okay, and then times dengan S. Macam tu, cos 0. Cos 0 is equal to 1 lah. So, you masukkan semua nilai. Okay, contohlah mass dia tadi dia bagi berapa. Kalau dia tak, soalan ni dia tak bagi mass kan, dia kata a block saja, awak jangan risau. Okay, biarkan saja jawapan tu dalam M pun boleh juga. So, dia akan jadi M. So, 9.81 sin 36.9. Okay, minus mu adalah mu dia bagi 0.18. Jadi kalau awak tengok kat sini, ini pun awak kena tinggalkan jawapan dalam bentuk M. M dia tak bagi mass dia. Awak jangan risau, awak kira je. Okay, M dia tadi kita dah factorize kan. So 9.81 cos 36.9. Okay. And then, semua ini tadi, sorry, kejap and then you timeskan dengan, semua ini tadi, you timeskan dengan S, which is 15. Okay, so, M tu tak ada, betul tak? M tu tak ada. So, you jangan risau. Okay, you jangan risau. This one is W net, which is equal to half mv squared. So, M tu nanti boleh cancel out. Okay, so W net from equation number 1, so half mv squared is equal to, M tu awak carilah berapa. So nanti dia akan jadi M, so this one is 9.81 sin 36.9, okay, and then minus, okay, 0.18 times 9.81 times cos 36.9. Okay. So, and then times 15. Okay. M tu nampak tak? Kita boleh cancel out. Finally, kita bolehlah kira. Kita punya V. So, akhirnya, V is equal to 11.6 meter per second. So, this is the answer. Okay. So, finish question 4A. So, let's proceed to question 4B. Alright, so now let's continue with question number 4B. So here we have a 0.6 Newton force is needed to compress a horizontal spring by 1.5 millimeter. Okay, so a 0.03 kg ball bearing is placed at one end of the spring, causing the spring to compress by 20 millimeter. So calculate the energy stored in the spring. Alright, now from the question, the information given. Okay, the first one is the force is equal to 0.6 Newton. Means that we need 0.6 Newton force in order to compress a spring. Okay, so the compression X is equal to 1.5 millimeter. So make sure you change to meter first. And then for the second case, so it states that when we put a ball bearing where the mass is equal to 0.03 kg, the spring will compress by 20 millimeter. Alright, so let's say this is X1 and this is X2. Okay, so 20 millimeter. Okay, so we want to calculate the energy stored in the spring when the spring compressed by 20 millimeter. Means that we want to find US, which is energy stored in the spring, and it is equal to half kx squared. Jadi ini merupakan spring yang sama, so that we need to find first what is the spring constant, K. So based on the information given earlier, so means that we can find K by using F equal to Kx1. So jadi ini adalah spring yang sama kan? So means that we need 0.6 force, okay, in order to compress a spring, alright, 1.5 millimeter. So based on this information, okay, disebabkan kita menggunakan spring yang sama, so kita boleh carilah dia punya spring constant, iaitu 400 Newton per meter. So the same spring is used when we put a ball bearing at one end of the spring so that it will compress by 20 millimeter. Therefore, okay, the energy stored in the spring should be half. K is 400, X is 20 millimeter squared, jangan tertinggal. Okay, and then the final answer is equal to 0.08 joule. Unit mesti betul. Okay, so this is the answer for 4B. So now let's proceed to question 5. Alright, question number 5. So here we have the eye of Malaysia as shown in figure 6 here. And the radius is equal to 68 meter. And the passengers in the capsules travel at angular speed. And please check the unit of the angular speed. So here it is given in radian per second. So tak perlu tukar lagi lah. Okay. And the weight of each capsule is 98 kilonewton. Alright, so now determine the magnitude of the centripetal force on a capsule at the highest point. So means that, okay, so this is the highest point at the top of the eye of Malaysia. Okay, so means that at the top of the position, we need to draw the forces. So we have normal force upward, and then the weight should be downward. So the weight of each capsule is given 98 kilonewton. Okay, and when the position of the capsule is at the top, means that the direction of the centripetal force should be towards to the center. Okay, jadi ini adalah dia punya center lah. So FC must be towards to the center. Alright, so now let's answer question A. Determine the magnitude of the centripetal force, where FC is equal to MAC. So in this case, FC is equal to, so soalan bagi kita omega here, where omega is 3.5 times 10 exponent negative 3 radian per second. So kita tak ada AC, ataupun kita nak tukar kepada mv squared over r, tapi kita tak ada v kan. So kalau you check dekat depan, okay, kita boleh juga kira centripetal force is equal to mr omega squared. So in this case, omega kita ada, r kita ada, but the mass of the capsule, we can get it from the weight of the capsule. Alright, so W is equal to mg, where m is equal to W over g. So boleh kira dululah what is the mass of the capsule, which is 98 kilonewton over 9.81. And then the mass should be 9.99 exponent 3 kg. Okay, so now we can substitute here where the centripetal force finally is equal to, the mass is 9.99 exponent 3, and the radius is given 68 meter, and then the omega is 3.5 times 10 power of negative 3 squared. Okay, and finally the centripetal force is 8.32 Newton. Okay, so very easy. And then for the second part, so let's read the question. Is the centripetal force on the same capsule at the lowest point the same as the highest point? So means that if the same capsule here is moving downward and finally it reached the bottom position of the eye of Malaysia here, so what is the centripetal force? So we want to calculate the centripetal force at this position. Okay, so in this case we can write the direction of the centripetal force still towards to the center. Okay, so if we write the equation of the centripetal force,
So it is actually equal to MAC. So in this case, if we change MAC, where AC is equal to V squared over R, so actually we can see here that the centripetal force is depends on the mass and also V, which is the speed, and also the radius, where all the values here is constant value. Okay, mass dia punya speed ataupun dia punya angular speed, which is omega, okay, ataupun R dia adalah constant. Therefore, bila kita kira the centripetal force, okay, walaupun dekat atas ataupun dekat bawah, kita akan dapat jawapan yang sama, iaitu 8.32 Newton. Okay, the magnitude is sama, but the direction is opposite direction. You can see here that the direction of the centripetal force masih dekat atas is pointing downward, okay, which is toward to the center. But when at the bottom here, you can see that the centripetal force is pointing upward, which is toward to the center. Okay, but how about the magnitude? It depends on the mass, V or R, ataupun kita kata it depends on the mass, R, or the angular speed. Okay, so therefore we can write the answer that the centripetal force at the highest point, okay, is the same as the centripetal force at the lowest point. Okay, so ini tertinggal. At the highest point is the same as the centripetal force at the lowest point, okay, because okay, the capsule, okay, travel at constant speed, okay, or at constant angular speed. Sebab apa? Sebab omega is equal to V over R. So V is the speed. So since the speed is constant, R is constant. So means that omega ataupun angular speed also constant. Okay. Jadi bila kita kira the centripetal force at the highest point or at the lowest point here, so you will get the same value, 8.32 Newton. Okay, means that the magnitude is the same. Since omega is constant ataupun dia punya speed, V dia adalah constant. So Fc is equal to mv squared over r. Kita mesti akan dapat magnitude yang sama. Cumanya direction of the centripetal force berbeza. Kalau sini downward, okay, masa dekat bawah dia akan jadi upward. Alright, so finish question 5. So let's proceed to question number 6.
Alright, so now let's continue with question number 6. Okay, so here we have 2 kg. So we start first. So we start with question 6a first. So a 2 kg object is connected to a spring and move in a simple harmonic motion. So given here the acceleration equation in terms of time, where A is in meter per second squared and T is in seconds. Okay, so selalunya kita nampak kan soalan kita jumpa dia bagi equation Y, which is displacement equation. So if the question give you equation of the acceleration, okay, which is equal to negative 0.4 sine 0.6 pi t. So now we should write equation of the acceleration in terms of time. So kita tulislah general equation dia adalah negative A omega squared sine omega t. So now based on this equation you can see here, okay, that this is the value of A omega squared. Bukan nilai A tetapi nilai A omega squared. Okay, di mana nilai 0.4 ini merupakan nilai maximum acceleration. So this is A maximum, okay, and it is equal to A omega squared. So in this case, A maximum is equal to 0.4 meter per second squared. Jadi kalau kita sketch graph acceleration against time, okay, nilai 0.4 ini merupakan amplitude of graph. Okay, remember kita recall balik. Okay, 0.4 ini merupakan amplitude of AT graph. Dia bukan amplitude of Y against T graph. Dia bukanlah maximum displacement 0.4 ni. Dia bukan amplitude A. Dia adalah amplitude untuk graph AT. Okay, di mana ini adalah nilai maximum acceleration. So now let's look at the first question. Calculate the amplitude and the period. So we want to calculate the amplitude and also the period. So based on the equation, okay, so we have information about A maximum, which is equal to A omega squared. Okay. And then remember from the equation, we also can get the value of omega, which is equal to 0.6 pi. Okay. So we can write that omega is equal to 0.6 pi radian per second, and A maximum is equal to 0.4 meter per second squared. So now we can calculate A, which is the amplitude. Amplitude dekat sini bukan amplitude of the graph AT. Amplitude dekat sini maksudnya A, which is maximum displacement. Okay, maximum displacement. Jangan keliru 0.4 tadi merupakan maximum acceleration. Maksudnya kalau kita sketch graph sine untuk graph AT, okay, nilai ini adalah maximum acceleration, dia merupakan amplitude untuk graph AT. Okay, so jadi sekarang bila kita masukkan nilai 0.4, saya tukar pen. Okay, 0.4 and A kita nak cari. And then substitute omega, which is equal to 0.6 pi squared, jangan tertinggal. Therefore, A is equal to 0.113 meter. So this is the answer. And then we need to find what is the period. So remember, omega is equal to 2 pi over T. So from this equation, okay, so T is equal to 2 pi over omega, where omega is equal to 0.6 pi. Okay, so T is equal to 3.33 second. Okay, so now let's move to the second part, which is calculate the maximum velocity. So remember, V maximum is equal to A omega. Okay, kalau tadi A maximum, okay, this is omega, and this is V maximum, where V maximum is equal to 0.113 and then omega is 0.6 pi. So finally, V maximum is 0.213 meter per second. Okay? And then the third one, calculate the total energy of the system. So this is very easy. The total energy of the system E is equal to half KA squared. Ataupun kalau kita tahu nilai K ini adalah M omega squared. Okay, kat depan pun dia tulis half M omega squared A squared, di mana K adalah M omega squared. So now let's substitute here. Okay, M omega squared A squared. So it is equal to half, and the mass is 2 kg, and then the omega is 0.6 pi squared. A is equal to 0.113 squared. So the answer is equal to 0.0454 joule, or we can write as 4.54 exponent negative 2 joule. Okay, so this is the answer. Very easy. And then we want to sketch a graph of displacement against time. Okay, so graph of displacement against time, remember, general equation for Y is A sin omega T. Jadi kalau kita tulis general equation kita, dia adalah Y is equal to 0.113 sin omega is 0.6 pi T. Okay, and then period kita dah cari tadi kan, that one is 0.6 pi T. Jadi tadi kita dah kira the period T is equal to 3.33 second. Alright, so now let's try to sketch the graph. So untuk graph displacement against time, dia adalah sine graph. Jadi bila kita sketch sine graph, so this is Y, in meter. And then T, okay, make sure you lukis guna pembaris lah Sekejap. Okay, so T is in second. So sine graph. So this is the graph. Okay, so the period should be 3.33. Kita labelkan lah. Okay, and this should be 1.67. And then the amplitude is 0.113. And here should be negative, negative 0.113. Alright, so next, sketch a graph of velocity against time. So, kita nak kira lah velocity against time. Kat sini lah saya buat So, remember general equation for V is equal to A omega cos omega T. Okay, so for velocity, okay, A omega tadi kita dah kira 0.213. So ingat ini adalah V maximum. Jadi bila kita sketch graph V against T, ini merupakan amplitude of VT graph. So bila kita sketch graph 0.213 itu adalah dia punya nilai amplitude. Kenapa? Sebab A omega itu adalah V maximum dia. So cos 0.6 pi T. Okay, so kita sketch graph. So this is V. The unit must be meter per second. And then, okay. And then here we have T in second. So dia adalah graph cos kat sini. Okay, so kita sketch lah graph kita. Cos mula daripada sini. To complete one oscillation. So T is 3.33. So this is the half oscillation 1.67. Okay. And then here is the value of 0.213, while this is the value of negative 0.213. Alright, so now finish question 6A. So let's proceed to question 6B. Alright, question 6B is about equation of progressive wave. So given this is the equation, okay, so where y and x in meters and t is in second. So now calculate the frequency and wavelength. So bila kita tengok soalan, pastikan kita tengok depan ni. Kalau ada nilai, kita tuliskan equation tu dengan betul lah. 0.002 sin. So 2 pi times 5 pi should be 10 pi t minus, so 0.08 times 2 pi. So 0.08 times 2 pi is equal to 0.16 pi x. So if we write the general equation of the progressive wave, it is actually equal to y equal to a sine omega t minus kx. Okay, so in this case, omega is equal to 10 pi, then k is equal to 0.16 pi. Okay, and then remember here we have negative. So this showing you that the progressive wave is traveling to the right. Okay, and we have another one here, which is the amplitude of the progressive wave is equal to 0.002 meter. Okay, jadi bila soalan pertama minta kita kira the frequency and the wavelength. So remember, in order to calculate the frequency, so we can use information from omega, where omega is equal to 2 pi f. So in this case, daripada equation tadi, okay, yang warna kuning ni, kita dapatlah nilai omega, which is equal to 10 pi. Therefore, we can find frequency is equal to 5 Hertz. Okay, very easy. So now we want to find the wavelength, where we can get the value of the wavelength, okay, from equation K is equal to 2 pi over lambda. So kita akan guna maklumat K, which is equal to 0.16 pi. So if we substitute here, okay, so 2 pi over lambda, and finally lambda is equal to 12.5 meter. Okay, so very easy. And then for the second part, the speed of the wave and determine its direction. So V is equal to F lambda. So remember, since the equation is negative, so maksudnya the progressive wave is moving to the right. So we can just straightly substitute 5. Lambda is 12.5. So the answer is 62.5 meter per second. Okay. And the direction is to the right. Okay, very easy. So finally, we want to find what is the displacement of the particle at a distance of 5 meter from the equilibrium position after 0.2 second. Okay, so for the third question, so we want to find what is the displacement. So we will use y is equal to 0.02. So make sure your calculator is in radian mode. So 10 pi times 0.2 second. Okay, masukkan nilai t dia tu lah, which is 0.2 second. Okay, and minus 0.16 pi. So the distance is given 5 meter. Kalau soalan bagi dalam sentimeter, make sure you tukar kepada meter. Okay, so masukkan situlah 5 meter. Okay, so tekan kalkulator elok-elok, pastikan kalkulator dalam radian mode. So finally, y is equal to negative 1.18 exponent negative 3 meter. Okay, so this is the answer for question B3. Alright, so now let's proceed to question C. Alright, so here we have an organ pipe and the length is given 72 centimeter and it is open at both ends. So it means that this is open pipe. So assume that the speed of sound is given 340 meter per second. So calculate the wavelength and the fundamental frequency. Okay, so remember the pattern of the open pipe. So the pattern of the fundamental mode is X shape. Okay, so saya selalu pesan ke awak, ingatlah shape ni. So X shape dia macam inilah. Kita ambil macam tu, X shape. So ini adalah antinode. So yang tengah ni adalah node and this is antinode. So if the question give you the length of the open pipe which is 0.72 meter. So let's write here 72 meter. So means that we can find the wavelength, tapi you kena tahulah pattern ini. So this is half lambda. Okay, so this is equal to half lambda. Okay, so now we can write L is equal to half lambda. Therefore, lambda is equal to 2L. So the wavelength for the fundamental frequency, okay, lambda 1 is equal to 2 times 0.72 and it is equal to 1.44 meter. So this is the answer. And then we want to calculate the fundamental frequency. Okay, so you must remember equation yang dah bagi kat depan, Fn is equal to Nv over 2L. Okay, so you want to find the fundamental frequency, right? So it should be F1. So N is the number of the harmonics. So fundamental frequency means that first harmonics. So V is given 340 over 2L. L also given 0.72. Okay, so don't worry, this equation is given. Okay, you dah ada dekat depan, so kita just kira sajalah. Okay, finally the answer is equal to 236.11 Hz. Okay, you can use this equation or you can use the second method. Okay, where we can use equation V is equal to F lambda. Alright, so now F, sebab kita dah ada lambda 1 tadi, lambda when fundamental frequency, sebab kita dah lukis dah ni, which is the first harmonics. So now actually you can find F1, which is the first frequency, is equal to V over lambda 1. Okay, so when you substitute the values, 340, lambda 1, kita dah kira dekat atas tadi, 1.44, you akan dapat jawapan yang samalah, iaitu 236.11 Hz. Okay, ada dua cara. Okay, tak pula nak guna yang mana, dua-dua pun betul. Alright, so now question number 2. If the fundamental frequency in C1 is the frequency of the source which is stationary, so means that here we have the source okay, which is this is the stationary source. So V equal to 0 meter per second. And then the frequency of the source, dia dah kata tadi, sama tadi dengan fundamental frequency yang kita kira dekat atas, 236.11 Hz. Okay? And then calculate the frequency heard by the child who is moving away from the source. Okay, means that we have a child. Awak lukis lah kat mana? Kat sini pun boleh. Moving away. So means that this is V of the observer, which is 2 meter per second. So now, if we sketch the wave of the sound, okay, so means that like this. So means that, okay, V, which is the speed of sound in air, which is the speed of sound, V should be towards to the child. So tadi budak ni tadilah. Okay, so dia bergerak. Okay, so maknanya bila kita lukis wave ni tadi, okay, from the source of sound here, so the wave will travel towards to the child lah. Dia mesti bergerak ke arah telinga budak ini. Budak ini yang nak dengar kan? So V mesti ke kiri lah, budak ni duduk di sebelah kiri ni. Okay, so V is equal to 340 meter per second. Alright, so now we want to calculate the apparent frequency, iaitu frekuensi yang akan didengar oleh budak tersebut bila dia jalan menjauhi source tadi. Okay, so kalau dia moving away from the source, okay, apparent frequency yang kita kira nanti mesti lebih kecil daripada frequency of the source. Okay, so remember the equation given. Okay, so V plus minus V0. So kat sini observer bergerak kan. So plus or minus kita tengok pada arrow ini. Arrow ini same direction kan. So remember, bila same direction yang dekat atas ni V plus minus V0, V observer. So bila same direction dia akan jadi minus V observer over V of the V plus minus Vs. Tapi sebab V of the source is equal to 0, tadi kan dia kata tidak bergerak, stationary source. So Vs kosong lah, so tak ada kat bawah tu. Okay, and then times the frequency of the source. So kita masukkan nilai dalam equation. So kita akan dapat 340 minus the speed of the observer over V 340 times the frequency of the source, which is 236.11. Therefore, FA, the apparent frequency, is 234.72 Hz. Okay, so this is the answer. Jadi kalau kita nampak dekat sini, okay, the value of the apparent frequency 234.72 Hz, which is smaller than the frequency of the source, iaitu 236.11 Hz. Okay, kita dah selesai soalan nombor 6. So let's proceed to question number 7. See you in the next session. Don't forget to like, share and subscribe channel Madam Fika Fiki. Jumpa lagi. Assalamualaikum dan selamat sejahtera.